Okay, very warm welcome to today's webinar on lab vacuum. Ladies and gentlemen, we would like to start just with a brief introduction, and there you can see the first slide. That means at the end of the session, we're having a Q&A session where all the questions you're having will be answered. Of course, in between, you can place some questions in the chat. That is no problem. But when it comes to the answering, please expect that to be at the end. You can have actually the set of slides, but for this, we would like to ask you to answer our last poll, our last survey, then we will let you have the slides. Screen arrangement, but I think that is clear to everybody. Adjust the settings for your preferred screen layout. That means full screen slides. Alrighty. So today's webinar is called Lab Vacuum Works Hard, so you don't have to. The level is actually for advanced beginners. And you will see our idea is to make your life easier so that at the end of this session, you will be looking as happy as that guy on the picture there. So let me introduce your hosts. That is Özkan Güneş. He is Market Manager Analytics at Pfeiffer Vacuum. So he is responsible for all the makers of analytical instruments because most of these instruments are coming with vacuum technology, with pump, with gauges, everything. So Özkan is very well aware of what needs to be done in order to equip GCMS, MS, whatever, what kind instrument, whatever, with vacuum technology. So thank you very much, Özkan, for being our host for today.
Yes, thank you. Thank you, Andreas. And your second host is Andreas Schophoff. He is the head of the market segment R&D, and he and his team are responsible for the R&D customers of Pfeiffer Vacuum worldwide. This includes, for example, universities or research institutions that conduct research using vacuum technology. And his role involves supporting these organizations by providing vacuum solutions to their scientific and technological needs. And yeah, now, Andreas, that the audience knows who we are, could you please tell us what is expecting us today in today's webinar?
Okay, ladies and gentlemen, we were actually thinking that vacuum technology for you guys is not really the most important thing because you're using your analytical instruments, but vacuum is not much more than a tool for you. And therefore, we had the idea that when it comes to participating in that webinar, to think of the expectations you guys are actually having. So, and from our point of view, we were thinking it could be good that you get a better understanding of how these vacuum pumps are working and maybe how to simplify your lab processes. And secondly, to explore the right vacuum solution for your needs. As you probably know, there is no perfect pump, but there is the one which fits the best to your process. And secondly, we were thinking it could be good to look at strategies to reduce maintenance efforts because that is something what you should not worry about. You should have that more like, switch on and forget. And again, that is what we were thinking. Now we would like to know what your ideas are.
Yes, sounds interesting, Andreas. And as you mentioned, we will have some polls in between. And there we are. We arrived at our first poll. The question is, which pump are you currently working with? I will just start the poll and ask you to provide some answers, please note that it is possible to choose more than one answer option. So there it is. Okay, I can see that, Andreas, it's pretty similar to the 2 seconds sessions that we had today. The turbo pump is the leading pump in this poll again. So this is,
Yeah,
I think
yeah,
we expected this.
right. Still, I would like to mention, Özkan, that we're not going to talk about high vacuum pumps like turbo pumps. We're going to talk about the working horse, as you've already pointed out. The working horse is more or less the backing pump. And therefore, I'm pretty happy that quite a few of those participants are voting for the scroll pumps.
Yes.
And yeah, that will be good. That will be interesting to let you have some insights and maybe have some new ideas of how scroll pumps can be used in your lab.
Yes, I like to call it the hidden hero, the backing pump. And as you've mentioned, this is going to be the topic of today's webinar. The focus will be on the backing pumps and especially on the vacuum in a lab. So let's go back to our slides and start with this section here, Andreas. Vacuum in a lab.
Özkan,
So
are you
now,
sharing?
sorry,
Ah,
now
yes.
you can see the screen.
Okay,
Sorry.
okay.
Yeah.
Now, yes, as you probably can figure, we like that picture of that happy guy with the foot on the desk and thumbs up. So vacuum in a lab is an interesting thing, and we would like to look at, first of all, where actually is vacuum been used, in what kind of instrument. We're looking at vacuum equipment, vacuum technology as a kind of an enabling technology. So first of all, from left to right, yes, most of it is just a backing pump for generating UHV. That is in all kind of instruments. That is in mass spectrometers, for instance, where you need to have a ultra high vacuum in very many cases, and these instruments, the turbo pump is part of it. It is integrated, and quite often the backing pump is standing aside the actual instrument. Same situation with the electron microscopes. The backing pump is standing aside. A bit of a different story with Schlenk lines or with glove boxes to the left and to the right, because there the medium vacuum pump is just the one which is sufficient for these kind of applications. Bit of a different story is the helium leak detector in the center here, because that for most people is just and only a black box, but everything is already in it. So these are typical applications. We're not at all saying that is the list which covers it all, but typical applications for vacuum in a lab. And now let's have a look at vacuum pumps in the lab and how it collaborates. So here in gray, we just were trying to mark this typical instrument as I've mentioned, and there's a housing in gray, and in that housing there's some kind of a sensor, and part of the sensor is the turbo pump. So it is a typical high and ultra high vacuum setup, and I think as everybody knows, the turbo pump is just working in a molecular flow regime, so it needs to have a backing pump, in this case a medium vacuum pump, and that can be anything. And for you, we were thinking is very important that this kind of pump is low noise, because quite often you're having more than one instrument in your lab, and you're very close to the instrument. So if it is clean and quiet, that could help. So just to have a look at the typical parameters, and one of the typical parameters is the final pressure these pumps actually can reach. So starting from left to right, we're looking at the rotary vane pumps, and there, yes, they generate vacuum starting from atmospheric pressure down to -3 hectopascal. The diaphragm pump is a dry pump, but it cannot reach such a low pressure, let's say 1 hectopascal. The scroll pump is absolutely comparable to the rotary vane pump, and it can go down into the same kind of pressure regions. Claw pump, yeah, that is another kind, but it is pretty big. You cannot figure that out. Multi-stage Roots pumps is coming into the -2 pressure range, and a screw pump. But you can see here to the very right, all these kind of pump technologies would be sufficient in order to combine with the turbo pump. Now, one second or a second parameter to characterize a backing pump would be the pump capacity. And starting here from left to right, so the diaphragm pump is just good for 0.1 to 3, 4 meters cubed per hour. For higher pumping speeds, the scroll pump is very well suited. So it starts at, let's say, 6 meters cubed per hour and something close to 50 meters cubed per hour. Close to that is a multi-stage Roots pump, which can go up to 100 or a little more. Then the two dark guys, the claw pump and the screw pump, they're having much higher pumping speed. That means they're more meant for evacuating big vessels. For the webinar for today, we are going to leave out the dark guys. So the claw pump and the screw pump will not be part of our webinar. But anyhow, just in order to give you an idea, let's say you're having a vessel with 1 meters cube, or 100 liters, sorry, 0.01 meters cube, and you want to evacuate that, having a pump with 10 meters cube per hour pumping speed, then it would take something like 2.8 minutes to get to 10 millibar from atmospheric pressure. And if it is just 1 meters cube per hour, yes, then it takes just 28 minutes. Just to give you an idea how pumping speed affects the time used to evacuate such a chamber. All right, so that gives you a bit of an overview. And now back to Özkan, please.
Yes, so I'm a bit of the curious guy today, and I think it's a good time to have a second poll. The question is, which pump feature makes your life easier? Considering the three pumps, so the diaphragm pump, the multi-stage Roots pump, and the high scroll. I will shortly start the poll. And there it is. So this time it's only possible to click on one answer option. Okay, I can see that it's going between quiet operation and minimal maintenance, but also no regular cleaning needed. Got some votes. but the leading answer is minimal maintenance required. So this is very close to what we expected, Andreas. Can show it in our next slide. One second, there it is.
Yes, very well. Like you said, Özkan, it is very much what we have expected. So we're trying to read your mind up front. And honestly, I think we did a good job because, yes, we were thinking what makes your life easier? Low maintenance, maximum uptime. So just and only switch on and forget. And secondly, quiet and comfortable. So that is something what we've mentioned already. When you're very close to the instrument, when you're having maybe multiple instruments in one lab, then it can be really, really annoying if it makes a, let's say, uncomfortable sound. Clean and contamination free, then it already comes to your application. Sometimes it needs to be very clean so that your measurement is not influenced, let's say, by any kind of oil backstreaming, something like this. So thank you very much for coming up with the results we were guessing you would have in your poll.
Yes, and this leads us to the first pump among the three that we will present in today's webinar. It is the diaphragm vacuum pump, and we have a video to illustrate its working principle, where you can see a so-called MVP from the Pfeiffer vacuum portfolio. So there we are. The blue arrows are representing the gas that is entering the pump and making its way through it. But to understand how it's work, we can take a look inside the pump. We see a crankshaft-driven rod that is moving the diaphragm up and down, or rather to the center and outward. And we can also see that the diaphragms are moving in a wavy pattern to push the gas towards the outlet. And looking at these round valves, we see that they are opening and closing alternately. And when the inlet valve is opened, the outlet valve is closed, and vice versa. And we can see the same diaphragm setup at the left side, meaning that we are dealing with a two-stage diaphragm pump here. And it is important to mention that the final pressure achievable with the two-stage pump is lower than that achievable with one stage, because it is compressed with an additional stage. So coming back to our presentation. Can here see some benefits and features of diaphragm pumps. First one is on-site service that is possible. It can be done by the operator, allowing the operator to easily replace the diaphragms and valves by himself. We as Pfeiffer Vacuum recommend the diaphragm replacement every 2 years, but depending on the application, rarely used diaphragms can be changed after 4 years. This is also possible. It always depends on the application, on the gases that you are pushing through your pump. You have less downtime as the diaphragm pump operates without oil, so it's a completely oil-free pump. You have a clean vacuum, and since no oil is required, of course, you also don't have any oil changes, which is clear. And the pump has a very high process durability and reliability. There is an integrated magnetic gas ballast, which reduces the risk of condensation, because condensation can be harmful to vacuum pumps by damaging the components of the pump, leading to the reducing of the performance. Furthermore, it is possible to have an automated gas ballast. This means they don't have to do manual adjustments. You can just tell the pump with this optional gas ballast to have gas ballast in certain intervals. It's just setting of some parameters very easily. And you can also have a retrofittable piezo Pirani sensor, which measures the intake pressure, enhancing the functionality of the pump. Quiet operation and low vibration. So noise always results from vibration, and this pump has a low vibration, which leads to a quiet operation ranging from 52 to 65 decibels. This is comparable to the sound of a normal conversation. And the last but not least, diaphragm pumps have a compact footprint, fitting well on workbenches without space concerns due to their small dimension. So to sum up our key findings, we have no contamination risks, no space concerns as we have a very small pump, and also because of the low vibration, we are having no disturbing noise pollution. And here we can see a typical pump down curve, in this case an MVP 15.2. It has a nominal pumping speed of 1 cubic meter per hour and can go down to 3.5 millibars. And when it comes to some higher pumping speeds, you can take a scroll pump. And Andreas, you are our expert for scroll pumps. Could you maybe tell us something about
Yeah,
it?
thank you very much, Özkan. So let me talk about scroll pumps. That is, let's say, quite new technology when it comes to vacuum pumps, and I would like to explain how it works. Here again, we're having a bit of a movie, and you can see here that is a rotor and a stator, and it looks a little bit like a spiral. The light brownish one, that is a tip seal, so which seals against the stator and the other way around, of course. Here you see very well how it works. So the bluish guys, this is the gas, and the gas is being compressed from the outside towards the inner part of this spiral thing, this orbiter. And the great invention of this scroll pump is that there are multiple compression stages. That means pretty much all these different gases like helium or heavy gases like nitrogen are being compressed in the same way. So if you're having a GC, for instance, and you're having helium, so that doesn't really matter for this kind of pump, it works. Here, that is the gas ballast valve that is very good in order to get rid of the water vapor, and that helps to get rid of other kind of vapors as well. So thank you very much, Özkan, for the movie. Now let's have a look at the main features and benefits. Again, it is an oil-free pump, pretty much the same like the diaphragm pump. It has some built-in intelligence because the fan, for instance, the cooling fan is sensor controlled, so there's no overheating. There is no risk of damage. Just to give you an idea, I mentioned that tip seal, and the pump is that way designed, so even without tip seal it could run. Of course, it would not have any kind of compression, but it would not be damaged. There would be no mechanical damage due to the missing tip seal. And therefore, yes, last but not least, you would not have any kind of unexpected downtime. Yes, after some time, some years of operation, it could have a not as good final pressure as it was in the beginning, but like Özkan already mentioned, for the diaphragm pumps, it refers exactly the same to the scroll pump as well. So depending on your application, how often you let it run, and maybe how it is being integrated into a system, let's say with the help of a little cable in between the turbo pump and the backing pump, uh, you have this intermittent operation, and the pump would just and only run if there's some gas load. So it would be very quiet, very low vibration. Uh, it is optimized for vapor handling. It has this smart operation. So with the help of built-in sensors, with the help of a gauge, it is very clever. The intelligence is already built in. It has this seamless integration, if you want to, together with the turbo pump. A little cable in between that will help. And it is this safe design. So even without taking too much care, it will be not damaged, even with not having any kind of a tip seal. So in a nutshell, there is no contamination risk because there's no oil. Even wrong operation would not have any kind of risk that oil, hydrocarbons, what kind of ever, would get into your analytical instruments. There is no oil spills underneath because, yes, it doesn't come with oil. And last but not least, there is no gas type dependent pumping characteristic that really helps for pumping light gases. And the next slide will let you have an idea how it actually looks in reality when it comes to the characteristic curve, when it comes to the curve of here one of these high scroll pumps. So you see here in blue nitrogen, green argon, and red is helium. And all these different gases are being pumped in the same way. Helium is even being pumped a little better than the others. So it is the perfect drop-in replacement for oil-sealed pumps. So for all these people who would like to get rid of oil-sealed pumps where they need to do uh, very often maintenance, oil exchange, or have oil spills, that can be the perfect drop-in replacement. Okay, it's gone. Now back to you. You would like to introduce the multi-stage Roots vacuum pump.
Correct. Exactly. So this is the, let's say, the biggest pump among the three that we are showing you today, which can reach the highest pumping speeds. And also here we are having a video to get a better understanding of how it works. And there it is. This is an ACP15 from the Pfeiffer vacuum portfolio. We can see the exhaust part on the bottom side, the inlet on the top side. And looking at the rear side, there is a frequency inverter and an air cooling system. And also here we are having a gas ballast on the top side. To understand how the pump works, we will take a closer look inside the pump. And there we see two synchronously counter-rotating rotors. They are rotating contactlessly without any friction in a single housing. And the rotors have an H shape, meaning they look like an 8 and they are separated by a very narrow gap. And as the rotor spin, the gas is drawn in through the inlet and enters the pump. Then we see it makes its way through all these stages. And stage by stage, it is getting more and more compressed, which is shown here by the change of the color from blue to red. And this stage by stage compression results in a higher pressure differential and an improved overall performance. features and benefits of multi-stage Roots pumps. As mentioned before, we are having, or we can reach very high pumping speeds, meaning that you have a very short downtime. As mentioned in the video, there is no friction in the suction chamber, allowing the multi-stage Roots pump to be operated at speeds going up to 6,000 RPM and allowing for rapid evacuation due to their high pumping speed. Optimized energy, meaning that these pumps maintain low power consumption despite this high pumping speed. And as shown in the video and explained, there is no friction between the rotors, which eliminates mechanical wear. And also this pump is working oil-free, so no oil changes are required. And despite the high pumping speed, it has a space-saving footprint, making it very easy to integrate into laboratory environments. Furthermore, constant vacuum stability, because they offer a consistent vacuum stability, ensuring the user a reliable long-term operation. They can be continuously operated at high inlet pressures, which is no problem for them. And the frequency converter, which was shown in the video, enables the operator to optimize energy consumption and reduce the noise level. And it is available in both single-phase and three-phase variations, ensuring consistent operation parameters regardless of the power supply or the mains frequency. You achieve an excellent process quality performance due to the particle-free and oil-free operation. And also here, again, our key findings for this pump are no contamination risk, and because of the frictionless operation, we have no mechanical wear and no particles in our vacuum system. And here is an example, in this case, an ACP90. You can see the suction speed curve. The main characteristic is, as several times mentioned before, the high pumping speed. Here we have 90 cubic meter per hour at its peak, and it can go down to 1 × 10 to the power of -2 millibar. So now we arrived at our recap. For this, we prepared a table to compare the pumps. We see quiet operation, long service intervals, level of final pressure, and fast evacuation. In terms of noise, diaphragm pumps and scroll pumps are, let's say, the winners, because multi-stage Roots pumps are a bit louder. But in terms of service intervals, we see that scroll pumps and multi-stage Roots pumps are better than diaphragm pumps. In terms of final pressure and evacuation, again, scroll pumps and multi-stage Roots pumps are the leaders. But please consider that you should always choose the pump that meets your requirements. And depending on your application, sometimes a small MVP, a small diaphragm pump, can be the best fitting pump. So it always depends on what you really need. So, and in the next slide, we will show you a video just to give you a feeling on how these pumps sound like. So there it is.
Very good, Özkan. That was absolutely impressive.
Yes, thank you, Andreas. So just to give you a feeling on how the sound is. It's very difficult to get the sound level, but to show you or to make you listen on the about the sound, I think it's a nice video. And yes, optimizing lab vacuum. Now Andreas will give you some tips to maximize your pump lifetime, and he will also show you an opportunity to save some energy with the high scroll pump.
Okay, thank you very much, Özkan. So let's start with the energy. I know that in, let's say, North America, energy consumption does not really, or energy saving is not really something what is very important, but at least over here in Europe, it is important. So we did look at it, but I will keep myself short. So it is the direct energy, so the electrical energy in order to get the pump running. Then, of course, the pump generates some heat, and for this, you need to switch on the AC. So, and this makes in total the energy consumption from the direct and indirect energy. That helps to see what can be done with the scroll pump in comparison to a rotary vane pump. So for the scroll pump, it is the addition of the direct energy, 380 watts, plus the indirect 127 watts. So that makes 507 watts. Looking at the rotary vane pump, that is 1500, same size. So sorry, same size, 1500 watts plus the indirect energy, so the AC, what you will need, and that is another 500 watts. Altogether, that makes 2000 watt. And comparison to the scroll pump, that is something like almost 1500 watt more what you put into a rotary vane pump than in a scroll pump. So for European standards, we did look at the price of energy, and that makes an yearly saving of 2,616. I know that is a bit of a different story. I was told in Tennessee, 1 kWh of electrical energy is about 8 cents. So that is a bit of a different story, but maybe one of these days that could be interesting for you guys as well. So more interesting should be the tips to maximum pump lifetime. So it is very much advisable to warm up the pump before you actually start your instrument. So that first of all makes, or is it good that you get rid of the water vapor? So it does not give you any kind of background from the water, which is actually in the pump. Secondly, the equilibrium of the pump, the temperature equilibrium will help to have the best performance of the pump. Then while running, you should use gas ballast. That very often helps in particular to get rid of any kind of vapor. It could be water vapor, but just as well other kind of vapors. And then adjust speed. This is what we've already mentioned. So have the pump not running always at full speed. First of all, it is annoying. And secondly, because of energy. So it is a good idea to have a little cable in between the turbo pump and the backing pump to make it run in lower rotation speeds. Just a little side note that just and only works for this kind of dry backing pumps, this dry medium vacuum pumps. It will not help for rotary vane pumps. So what we suggest, after your process, let the pump run for some time in order to get rid of any kind of water vapor, whatever sort you're having in the pump. So that makes it easier for now, and it makes it easier for the next startup. Then we were looking at the different kind of situations. So most of the time it is like you see here to the left. That means it is a one-to-one connection. Like we've already mentioned, there is one instrument here with the turbo pump and one backing pump sitting besides the actual instrument. It could be just as well such a multi-instrument connection. So we are having, in this case, 8 different kind of instruments and just 2 backing pumps. That helps you because that means it is just 2 backing pumps you have to consider for maintenance. It is just 2 backing pumps which are running and making noise. So it does have multiple benefits over this one-to-one connection. Let's say the gold standard when it comes to central vacuum systems would be the one to the right, where you have multiple users needing vacuum, and the system, the central vacuum system, actually would be placed in the basement of universities or institutes or even hospitals. But then, of course, we would look at quite big pumping stations which supply the entire building with vacuum. And how it looks like in reality, the next slide will show you. Yes, so starting again from left to right. Left is the one-to-one connection. It shows an electron microscope and a backing pump. So pretty much what most of the people are running in their labs. The one in the center, the picture up, is showing multiple instruments and is showing just 2 backing pumps which are pumping all these instruments. As I've mentioned, that can be a good idea when you have the piping to have just only 2 backing pumps to have them connected to all these instruments. So it is a kind of a cluster solution, and the one to the right, this full central vacuum system, that would sit in the basement and is meant for providing the entire building. You see not just only the pumps, but you're having some vacuum vessels in between, which provide always the right kind of vacuum for the entire building. So just to summarize, that kind of different scenarios can make your life easier. Well, for the time being, you might have just this one-to-one connection. We are just suggesting it could be worthwhile to think of different solutions.
Okay. It has been a long time since our last poll, Andreas.
Yes, now it's time, Özkan. May I introduce?
Yes,
This
of
is
course.
Özkan the sorcerer. So you guys, please imagine he is a sorcerer and has a magic wand in his hand. So if you had one wish, what superpower should your pump have? Özkan actually can make it happen. So that is the question. What kind of superpower of your pump would you, Özkan, to realize?
Yes. I just started the poll. So please feel free to give us an answer.
Yeah, I can see, Özkan. Most of the people would like to have something where they don't need to worry at all. So switch on and forget. So that seems to be exactly the product you need to generate with your magic wand.
Yes. A maintenance-free operation. Okay. thank you for participating at our last poll. Yeah, Andreas, you showed us some tips and tricks to maximize our pump lifetime and to make your life even easier. We have a tool which is called the vacuum calculator. It can be found on our Pfeiffer Vacuum website. And to show you how it works, we again having a video, and we will do or calculate an example and see what the result is at the end. So there it is. You can find the Pfeiffer vacuum calculator on our website. It is free for all. You just go to the knowledge section and then there it is, the vacuum calculator. It is possible to find a suitable vacuum pump solution to calculate the pumping curve for a vacuum system or just perform a simple vacuum calculation. For this example, we will try to find a suitable vacuum pump solution. And then we click on evacuating a chamber, and now the tool asks us to give him some parameters. We say that we want to reach the pressure 2 times 10 to the power of minus 2 millibar, and the target time for this example, or for simplicity, we say it is not important. And the next step is defining the geometry. We just say that we are having a cubical chamber with this dimensions. We click on next, then there is the desorption rate. And here you have the option to add some surfaces. But again, as this is an example, we will just skip this one and calculate with the standard value provided by the system. And we do the same for the leak rate, as there is a value already in it. And for the pipe length, we also calculate with the standard value, and we say that there is no piping between the turbo pump and the chamber. And as we are having only dry pumps in this webinar, also here we are choosing a dry pump, and we ask the system to propose equal numbers of backing pumps and main pumps. Of course, this is just an example. It could be that your application looks different than this one here. And there it is, the system or the application is recommending a high scroll 6. And if you click on it, you will be directed to our digital catalog where you can choose between the pump. And it is important to mention that this is just a tool to give you a first impression. It does not replace the direct contact to our sales engineers, but to have a first idea, it is very nice to use. So now we are nearly at the end of our presentation. It's time to have a recap, Andreas. We had these 3 bullet points which were understand, explore, and learn. Could you maybe recap on our achievements? Did we reach the goals? What do you think?
Yeah, thank you very much. You guys remember we were thinking this could be actually the expectations you're having on that webinar. Of course, we couldn't have asked you up front, but we understood, yes, it could be the best thing what you can expect to understand how vacuum pumps can simplify your lab processes. And so we did explain how it works, what are the features and benefits, what are the actually situation when it comes in a nutshell, how it works. So I think we did let you have an understanding of how the pumps are working and how they can simplify your process. So suction speed, noise, maintenance, and final pressure, all that we were talking about. When it came to explore the right vacuum solution for your need, we did mention clearly, yes, there is not one perfect pump for it all. I mean, yes, we do have a sorcerer here amongst us, Özkan, but still, it is not the perfect pump on the market available. So we were talking about other kind of solutions like centralizing, and we were looking at the vacuum calculator tool, which is free to use. You can play around with it, and it would be great if you could let us have some feedback. Then learn. We said yes. it is advisable to warm up the pump and to use gas ballast and speed control that makes it even quieter in your lab. So I hope you all will agree that we, or me personally, I think we did achieve the expectations. If not, please don't hesitate to reach out to Özkan or me or anyone from the Pfeiffer Vacuum organization for further discussion. And now we're open for your questions.
Yes. So as you may see, there is a chat, and you can feel free to just type in your questions. We still have time to answer it here. As mentioned in the beginning, you will receive the presentation. You just have to participate on the survey after closing this application. And you also have the opportunity to scan this code here, which leads to our LinkedIn profile. So you can also ask the questions afterwards.
Yeah, so please feel free. We'd be happy to do our very best to answer your questions.
So let me take a look into our chat. Okay, there are no questions yet. Yeah.
Yeah. Özkan, you did a great job being a sorcerer.
Yes. Now there is a question. So how loud is the RVP compared to the dry pumps? This is one question from our audience.
That is an interesting question. So first of all, as we said, the RVP always needs to run at nominal speed. So there is no way of, let's say, using it and switching it off or having it run in a lower rotation speed. It not just needs to run. And therefore, it is quite a bit more noisy than the scroll pump, and it has sometimes, it depends a little bit on the size, a squirking noise, a high-pitched noise. So it is not that comparable, but we are going to have another kind of video which actually gives you an idea, or as Özkan pointed out, to get a feeling of what is the difference, because it is not just only the noise itself, it depends on the frequency.
Okay. Then we have two more questions. There is one regarding a vacuum controller. So the question is, what solution do you offer in terms of vacuum controller? So in terms of vacuum controller, we are having the OmniControl, which is communicating via RS485. It is very easy to handle it, and it can just be plugged into your, for example, scroll pump or MVP together with the high pace pump. A very easy use, right, Andreas?
Yes, and that is the beauty of it, because that controller would control not just only the pumps, turbo pumps, backing pumps, but the gauges, and it could open and close the valves as well.
Exactly.
Özkan, there's another question. Are your pumps suitable for acetone extraction? I need a pumping speed of 1.5 meter. Sorry, I don't see that.
So are your pumps suitable for acetone extraction? I need a pumping speed of 1.5 cubic meter per hour and obtain final pressure of
5 millimeters mercury. Yeah.
You know this unit?
Yes, of course.
Okay.
That is a bit of a tricky thing. Most of the pumps are coming with some elastomeric sealing, and acetone is, of course, some solvent which really has some effect on elastomeric sealing. We have to look at it, but by the first sight of it, um, the best would be an ACP because there are pretty much no elastomeric sealings in.
Mhm. Okay. Another question regarding scroll pumps is there any contamination with some kind of dust of the tip seal?
With the new scroll pumps, yes, there is some rub off coming from the tip seal, but nowadays it is very much minimized. So we did already do some tests compared to these multi-stage roots pumps, and we found there's not that much of a difference.
Mhm. Okay. Yeah, no more questions are arriving. So, as mentioned before, feel free to reach out to our LinkedIn profiles. You can also ask your questions directly to us, and we can answer them afterwards.
Yeah. So, ladies and gentlemen, thank you very much for participating in today's webinar. We were very happy. All right, there's another question. What steps are recommended to vacuum high? Hang on, what was it? What steps are recommended to vacuum a high vacuum? To evacuate a high vacuum system to reach high vacuum. The high vacuum system has one roughing pump and one turbo pump.
Mhm.
Yeah, okay. Good. So that is, of course, something depending on the size, but of course on the material and the surface. Because in this kind of region, in the -8 region, we're already looking at high vacuum, and there the desorption coming from the surface of the chamber is the, let's say, one of the most important factors. So therefore, it is advisable to have a combination of a turbo pump and a backing pump, which actually can compress the water, but which can compress the light gases. I think everybody is aware, even in this kind of pressure, the dominating gas is hydrogen. It starts going to be, the further you get in the low vacuum side, that just and only hydrogen is the remaining gas. So to keep a long story short, a high compression turbo pump with a scroll pump could be a good solution for generating high and ultra high vacuum.
Mhm. Yes. There's one more comment, Andreas. Great webinar. Thank you.
Thank you very much, ladies and gentlemen. We're very happy, and we really had fun at SCAN, right? We had
Yes.
fun
Yes.
doing that webinar.
Yes.
And like Özkan mentioned, please feel free to reach out to either Özkan or me. We would be glad to do our very best to answer all your questions. Otherwise, don't hesitate to contact our sales guys, and they will help you as well. Thank you very much again. Have a
Okay.
great day, and see you later.
Have a lovely day. See you next time.